Okay, so we are looking at graphing in slope-intercept form. So first of all, we need to sort of figure out what in the world slope-intercept form is. You are correct. Slope-intercept form. Y equals, I'm going to use different colors because I've got them, so why not? Y equals M X plus B. Now, some of these pieces you're familiar with, maybe some of them you're not. X and Y, we've been dealing with those plenty, right? M we've been talking about for the last couple days, so that's just your value for slope. And then B is what I was just talking about on that other page. That's your y-intercept. So in other words, this is where your graph is going to cross the y-axis. And that's where we're going to start, okay? I'm going to give you a couple of steps. Yeah, I'm going to give you a couple of steps. Today, step 1 will be pretty much done for us, but tomorrow it won't be. Okay, so how to graph step 1, you want to get your equation in slope-intercept form if it's not already. So you want it to look exactly like this. You want y all by itself, y equals x, and then some number over here. So you could have, you can have a number for m and you can have a number for b. You could also not have a number for either one. We'll talk about that. So first, get your equation in slope-intercept form. Okay, so again, we're going to practice more with that tomorrow or Friday if we're not here tomorrow. If step 1 is already done, then you are going to put a dot on the x-axis, on the y-axis, at the value of b. So actually, why don't I give you, I have a paper for us to do. Okay, so if we were just going to do number 1 on this paper, as we read this example, right? It says y equals 2x plus 1. So what is, well, let's go ahead and identify these. What is the slope in this? 2. Whatever number is in front of the x is your slope. So the slope is 2. And then what is the y-intercept? Positive 1. And this right here is where most kids, if they're going to make a mistake, it's right here. If you're going to graph, this is where you start, the y-intercept. So that's what we have let's look at our how-tos. Step 1, get your equation in slope-intercept form. It already is. The y is by itself. I have y equals mx plus b. I'm good to go. 2, put a dot on the y-axis at the value of b. So b in this case is 1. So right here's where many kids make a mistake if they're going to. I need to put a dot on the y-axis. Which one is that? The vertical one. You should put a dot at 1 right there. That's a point on your graph. That's kind of where your whole graph, well, I don't want to say it starts, because it's a line that goes on forever. So how do you start forever? But that's where it's going to hit the y-axis. Okay, now we're ready for step 3, which is, well, from that point, you're going to follow your slope. Follow the slope to get to the next point from the point you just made. So you just put a dot on your line, on your graph, right? That's a point on the line. You have one. You really just need one more, right? Can't you make a line out of any 2 points? You just connect any 2 points, right? You can just connect the line. So I really just need to go ahead and from the point that I was just at, I want to follow my slope. Now, the slope is 2, but I like it as a fraction.
2/1.
That is the same thing as 2/1, right? Right? Same thing. So, here's how we go. Remember, that's the top number tells you how many to go up. The bottom number tells you how many to go to the right. Well, okay, so it can get a little confusing. Let's say this should be up or down. If it was negative, I'd be going down. But the bottom number should always be positive, so you should always be going to the right. There are some exceptions, and we'll talk about those when they come up. But the top number should be positive or negative, and that tells me up or down. And then the bottom number should be positive, and I should be going to the right. So from the point that I just made, I'm going to go up 2 more boxes to the right one. And you can do it again. You can go up 2 more to the right 1 more, up 2 more to the right 1 more if you want. So see how I'm creating this line now? This grid is a little small, sorry, but hopefully you get the idea. And we should be connecting the dots. There is the graph of y equals 2x plus 1. So, yep, the only other step that I might add to this is connect the dots. Okay, so let's try number 2. You've got y equals 3x minus 4. So what's the slope in this case? Careful. Your slope is 3, so I'm going to write that as 3/1. And then what's the y-intercept? -4. So when I go to graph this, where do you start? Where? The y-axis. So I'm actually going to go down 4. 1, 2, 3, 4. And I put a dot there. Is that what you did? Sorry, the graph really is tiny. The grids. But we got it. And now I follow the slope. So the slope tells me to go. What does my slope tell me to do? Thank you. Yes, 1, 2, 3 to the right 1. You can do it again. 1, 2, 3 to the right 1. 1, 2, 3 to the right 1. There's no set number how many you have to do. You really only have to do 2. Another thing you can do to quickly check, I mean, this doesn't guarantee you that you're right or anything, but you know if the slope is positive, your graph should be doing what? Going up. So this had a positive slope, my line is going up, so that makes sense. When I start to do ones that are negative, it should be going down. Okay, so let's look at 3. What's the slope this time? 2/3, and then the y-intercept is 5. So I'm going to start here. You always start at the y-intercept. Always, 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 always. So let's count up to 5, put a dot. And now, where do I go?
Up 2/3.
Right, because remember, it's up and then to the right. So I'm going to go up 2 to the right 3. So do you see now why fractions are so much better? If that were a decimal, 0.6 repeating, what would that mean in terms of my graph? It'd be crazy, right? It would make no sense. So you actually prefer fractions here, because going up 2/3 is very easy to do. But a 0.6 repeating as a decimal, that means nothing. So from my point, I'm going to go up 2, 1, 2, to the right 3. 1, 2, 3. You can do it again if you like. You can go up another 2, over another 3. Up to you. And I should be able to make this line. My slope was positive. It should be going up. It is. So that's cool. Before we go on to 4, I actually want to talk about the difference between 2 and 3 real quick. So look at 2 and 3. Is everybody looking? I want everybody to pay attention to this. So 2 and 3, they're both positive slopes, and they're both going up. But this guy is an awful lot more steep than this one is. Why? How does the slope relate to how steep the line is?
Oh, it's like, I guess you look at but makes it, oh, like I guess more that way.
You were on the right track. Olivia, what do you got? Not necessarily. Ariel? This is the sheet they're doing right now. Yes, you're spot on. Look at what the numbers are. You're comparing the number 3 and the number 2/3. Who's bigger? 3. The bigger the number is, the more steep the line's going to be. So if I were to graph something that had a slope of 10, would it be steeper than this or less steep? Even more steep, because that had a slope of 3 and it's already pretty steep. So a slope of 10, and for all the reasons you guys are saying, because I'm going to be going up more units than I'm going over. If I go over more units than I go up, then I get something that's not quite as steep. So if you look at this one, right, I went up 2/3. I'm going over more than I'm going up. So I'm still going up, but at a much slower rate. So basically, the bigger the number is, the more steep your line is. So if I were to graph something that had a slope of 1, how would it compare to these two graphs? Would it be steeper than this one? Less steep than this one? Somewhere in the middle? Olivia, what do you think? It'd be in the middle. Because 1 is in between 2/3 and 3. So it wouldn't be quite as steep as this line, but it would be more steep than that one. I actually have a little activity. Maybe we'll do it on whenever we're here again, where you compare a whole bunch of lines and you put them in order from how steep they are to how not steep they are. All right, anyway, 4 now throws us for a loop because it does not look like y = mx + b. But is something jumping out at you? Oh my gosh, whenever I see this, I'm supposed to think of Hoivux. Exactly. I only have one of the variables. I don't have an X and a Y. So whenever you only have one of them, that's Hoivux. And then let's see how we kind of interpret this one. It's Y equals 7. So which one am I dealing with? Hoi. So let's get rid of Vux. So I know the equation. What's the slope? 0, right? So the slope is 0. Now I don't get the y-intercept from this. It is 7, yeah. So your y-intercept is just going to be 7 here because think about what's going on. It's a horizontal line at 7. So where does it hit the y-axis? At 7. So yeah, anytime you see x equals a number or y equals a number, just ding, 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 that's a Hoivux, because that's not in slope-intercept form. You would just do a horizontal or vertical line. Okay? I want you to jump to 6. What's the slope this time? Yes, and watch how I want you to write this. Is everybody watching? Look close. Look really close. Look how close. Do you see? Do you see what's going on here? Oh, geez, it's shaking so much. Okay, look at this. They have this negative just sort of floating out in front of the fraction.
Just move it up to the numerator.
Thank you. When you write your slope, you're just going to write it as -1/3. Don't have that negative floating out in no man's land. You got to write it -1/3, like that. Because remember, that negative tells me what to do. This now means go down 1 to the right 3. If you just have the negative floating out in front, well, what do? Where are you going? What's happening? It's so confusing. It's not confusing if you just put that negative right in there with that. Okay, what is the y-intercept? 5. Okay, so now we know where to start. We'll put a dot at 5. And then we're following the slope. This time it's negative. So remember, this means go down 1. I'm still going to the right 3. That's another common mistake, is that kids go down and to the left. That's not what you mean. You're always going to go to the right. It's very rare that you ever go left. So down 1 to the right 3. Down 1 to the right 1, 2, 3. Down 1 to the right 1, 2, 3. Here is my line. Now, what should my line be doing? If I have a negative slope, what should my line be doing? Going down from left to right. That takes half a second to check. You know it should be going down from left to right. Someone that makes the mistake of going down 1 and to the left 3, their graph is going to go up. So if you at least do that quick check and you're like, ooh, it was supposed to go down and mine's going up, something's not right. You can catch yourself pretty easily with some things like that. Okay, does all this make sense? All right, guys, so for homework, I would like you to finish these, including number 5. So don't forget about number 5 if you haven't done it yet. And then all the ones on the back. There's not too many. You have 6 minutes. I bet you anything you could get it finished. Yeah, they're pretty fast if you know what you're doing. Yeah. I'm going to sketch a couple on our note sheet just so we have them. Yep, Pablo.
I have a question.
For number 10?
Yes.
Yep. So, did you do Hooyvox?
No.
Should you?
Yeah.
Yes.
No, like like will it be the y-intercept?
Does it cross the y-axis?
No.
So then there isn't one. Yeah.
And what would be the slope?
Do Hooyvox. What does it tell you? Yeah. Oh. Okay. Oh, this is still recording. Oh, for Pete's sake.